All right. Good morning, everyone. Today, we're going to continue looking at the model of the atoms. Specifically, we're going to start off with the helium atom and a beryllium atom. And we can see, hopefully pretty clearly, that we've got some protons, neutrons in the core and the nucleus of our atoms, and some electrons orbiting around the outside. The text part that's cut off, unfortunately, basically what I'd like you to do is compare these two models, and I'd like you to come up with two similarities and two differences for them. And then I'd also like you to think, based on those models, why do you think helium is number 2, the second element, and beryllium number 4, the fourth element of the periodic table? So we're going to pause here, take 5 minutes, see if you can figure that out, and we'll discuss it, and I'll have you share your ideas in just a moment. So I'd like to look for just a couple of volunteers who would like to share some of the similarities and differences, and we can write those on the board briefly. Hopefully we should see that, so we could say things like they both have a nucleus, they both have protons and neutrons, they both have electrons, maybe they both have 2 electrons on the outside. Those are all possible similarities. Some differences: beryllium maybe has a bigger nucleus than helium does. Beryllium has more electrons. Beryllium has more rings that those electrons are found in. All those would be reasonable. Hopefully we can also see that there seems to be a direct relationship between the number of protons, neutrons, electrons, and the location of that element on the periodic table. So the plan for today is working in small groups of 3 or 4 students. You guys are going to be working on decoding that pattern. You are going to need your periodic tables for this. If you don't have one, you should have some in your agenda book. Not the greatest of periodic tables, but will help us through what we need to work on. So once everyone gets a paper that's labeled atoms by number, you guys can get together in your groups, and we're going to spend just about the rest of class working on that. So we're going to pause here. You guys can get to work. So some of the things that I want you guys to be familiar with. One of the really useful pieces of information we can get from the periodic table is the atomic number. The atomic number, most importantly, is the number of protons in the nucleus. That's the direct relationship. Atomic number, number of protons. It may seem coincidental that that number also represents other quantities. For example, maybe the number of neutrons or electrons, but that doesn't always work. The atomic number is always going to be equal to the number of protons. And therefore, every new element, as we move up the periodic table, is going to have another proton, and is therefore going to have a larger atomic number. The other piece of information that's really important is the atomic mass. The majority of the mass of an atom comes from its nucleus and what is found in the nucleus. So that would include our protons and our neutrons. Those account for most of the mass of an atom. Therefore, if we know the atomic mass, the total mass, and we take away the number of protons, or the mass of our protons, same idea, we can figure out the number of neutrons. So to figure out the number of neutrons, you take the atomic mass and you take away the protons from it. We can switch that around using some simple math, and the idea is the atomic mass is equal to how many protons you have and how many neutrons you have. we're going to see later on that the average atomic mass is going to be a little bit different, and we'll talk about why that's the case. Applying this idea to what we've talked about so far in terms of being able to produce elements like gold, like the early alchemists did, if you had an element and were able to add protons to it, you could theoretically change the identity of that atom. Add enough protons and you could reproduce gold. This is something we're going to look into a little bit more, seeing how feasible that is. Now, with the remainder time in class, I'd like us to use your periodic tables, and I want you to identify these elements. So based on an element that has the atomic number 18, an atom that has 3 electrons when the atom is neutral, and one that has atomic mass of 16. So take a moment, write down your answers, share it with a neighbor, and see if you can both agree. That's all I have for today. If you guys have any questions, please hold on to those until Wednesday, and I will talk to you about them.